going to look now at an example of a graph that tells a story. This is Michas Travels. For this example, at 11 o'clock, Misha's mother sends him to the corner store for milk and tells him to be back in 30 minutes. And here is the graph of his walk. The horizontal axis is time, and the vertical axis is his distance from home. So we can tell that right here, down here at A, this is when Misha starts. He starts right here. The distance from home is 0, so he starts at home. Now, when you look at this graph, you see that some parts of the graph are steeper than others. Why do you suppose that is? Well, some parts are steeper than others because, as you saw when we were looking at the stories, the walkout stories, a steeper line means he was moving faster. We can actually calculate the speed that he's moving by using this graph. The speed is called the rate of change. And we're going to look at each of these individual line segments. So we're going to start with A to B. And what we do is we make what's called a rate triangle. So on my graph, I draw a little right-angled triangle from A to B. We call the vertical distance the rise, and we call the horizontal distance the run. So to calculate the rate of change, we have to see what the rise is. Just because this is 4 squares does not mean that the rise is 4. You have to look at the scale. So when you look at the scale, you can see that the rise goes from down here at 0 up to 200. So the rise is 200. So we write that down. I don't write very good on a computer. And the run, the distance across here, is 4. So when you calculate that, 200 divided by 4, you get 50. So the speed here is 50, and our units are meters per minute. Now we're going to do the same thing for the next section. We're going to go from B to C. So you make a rate triangle that goes from B to C. So the distance this time we're looking at from here to here is from 200 to 400. So the rise is 200. The run goes from this point over to this point. So it's going from 4 to, that's a 12 down there. So from 4 to 12 is 8. Now 200 divided by 8 is 25. So the speed that Misha is moving in from spots B to C is 25 meters per minute. So you can see that it's less steep, and you know then that it's not as fast. Well, now we know that the speed is 25. From C to D, we'll do that one the same way. Make your rate triangle. It goes from C to D. The rise is going from 400 to 600. So that's a rise of 200. And the run is going from here to here. And it's 1 square. And on my graph, 1 square is 4 minutes. And we already calculated 200 divided by 4. And that is 50 meters per minute. Now when we get here, from D to E, from D to E, my line is horizontal. I stayed, or Misha, I should say, stayed at a distance of 600 meters from home. Well, that just means that his rate of change, his speed, he did not rise at all. The rise was 0. The run was the amount of time that he was there, was 4. And 0 divided by 4 is 0. Oh, and for some reason I have 2 of these, so we don't need that one. Then we'll do from E to F. All right, from E to F, the direction has changed. So now, because the line is going down, that means that Misha is heading back towards his home. The rise goes from 600 to 500. So the rise, we actually say the rise is negative 100 because it's going back down. And the run goes from 20 to 28. That's a run of 8. Now, when you take 100 and divide it by 8, you get 12.5. And because we want to show that this is a different direction, it's going back towards home, we make it a negative. Now for the last section, from F to G. So we go all the way down and over. The rise here, we're at 500 to 0. So that means the rise, we're going down 500. And the run goes from 28 to 40. So that is a run of 12. So this is a negative divided by a positive. It's going to be a negative because it's going back down. And 500 divided by 12 is 41.666, repeated forever. So I'm going to round that to 41.7 meters per minute. Part C. Over what intervals of time is Misha traveling the fastest? So let's go back and we can look at either our graph and see what's the steepest, or we can look at our times and see what is the biggest speed, I should say. There's a 50 and there's a 50. So those are the fastest. So in sections A to B and sections C to D, that's when he's traveling the fastest. So A to B and, what did we say? C to D. Whoops. A to B and C to D. Next question. How long did it take Misha to reach the store? So let's look at our graph. We know that he started down here at part A and he reached the store, where do you think? Yes, he reached the store here at D. So when we look at the graph, D is at 16, so it took him 16 minutes to reach the store. How long did he stay at the store? Okay, let's go back. D to E is when he did not go further away or move back home, so that's when he must be at the store. And from D to E is from 16 to 20, so that is 4 minutes. How long did it take Misha to get home? All right, going home is from E all the way down to G. So if he started at 20 minutes and got home at 40 minutes, that distance from 20 to 40 is 20 minutes. How do you use the graph to tell which direction Misha is traveling? Well, we talked about that. As my graph is going up, Misha is traveling away from home. And as the lines are going down, Misha is traveling towards home. Oops, we don't need caps lock. Going up is away, and going down is towards. Did Misha make it home in 30 minutes? Look at our graph. Ah, no, 40 minutes.